Welcome back to College Algebra. In this lecture video, let's take a look at how we can determine whether the relation represents a function. So basically, right now, all these equations I have on the lecture handout, I'm going to treat them as a relation. Okay, I know we define the word relation as a set of ordered pairs. Okay, but we can also say any type of equation can also be called as a relation, because if I have an equation and I can actually find points, I can actually find coordinates. Okay, therefore, coordinates and equations, both of them can be defined as relation. So determine whether the relation represents y as a function of x. Okay, so for all these equations down here, for me to determine whether these relations represent y as a function of x, we got to solve for the variable y. All right. So the instruction here is once I solve for y, okay, if it does represent y is a function of x, then we need to write down the domain as well. All right. So let's solve for y. X minus 7y to the third equal to 0. So right now, I really have no idea whether this is a function or even not a function. Okay, that's why I want to solve for y first. So as you can see, I got two terms on the left side. My variable term solving for y is negative. So if it's negative, I can move it over. So that will give me positive 7y to the third on the right. Okay, x is still x on the left side. All right, to get y by itself, I need to first divide it by the coefficient 7. So now I'm having x over 7. So this is y to the third equal to x over 7. All right. Now if I take a cube root on both sides, then my y is now equal to, now when we take a square root on both sides, the answer is always positive, negative, but not with the odd roots. There's going to be cube roots of x over 7. Okay. So is this a function or not a function? Or what type of function is it? So if we go back to the second objective here, this is a cube root function. All right. This is actually cube root of x, except now I'm having a 7 in a denominator. So basically I can look at this problem and think about it as cube root of 1 over 7 times x. 1 over 7 times x. So if you take away the coefficient of 1 over 7, this is a cube root of x. So this is actually considered as a cube root function. Okay. So yes, it is actually what? It is actually a this relation does represent y as a function of x. Okay, because this is actually considered as a cube root function. So here we go. I'm start adding ingredients, okay, to my basic, to my ice cream here. All right, so I'm just basically adding a coefficient right in front of it, but it's still cube root function. All right, so what is my domain? If it's a cube root function, it should look something like this. Okay, so I'm gonna graph it just to see exactly what this thing look like, so I can write down my domain. So I'm gonna go to y equal. I'm gonna say math, press number 4, cube root of x over 7, close parenthesis, because x over 7 is inside the cube root, and graph it. So it does look like the regular cube root function. So my domain got to be from negative infinity to infinity. All right. So I'm looking at, even though my answer is this, but I can rewrite it this way to help me to see that this is a cube root function. All right, let's try another one. x squared plus y squared equal to 1 is this relation represent y as a function of x. So I got to get y by itself, solving for y. So my variable term is positive. I'm going to let it stay. So move the x squared over. So that give me y squared equal to negative x squared plus 1. To get y by itself, I will need to take a square root on both sides. So I get y equals positive and negative square root of negative x squared plus 1. All right, then when I take a square root, my answer is actually positive and negative. So basically what I got myself here is actually two different answers. One of them is actually y equal to positive square root of negative x squared plus 1. The other one is a negative one. So if I ever want to take a look at, so this is not a square root function because I actually have a square. Okay, this is not the typical square root function because my variable is not just simply an x, it's actually x squared. So we still consider this as a radical, each one of these is still considered as a radical function. Because I have two answers, then I have to enter in both of them together to make it into one graph. So if I just say square root of negative x squared, individually they are radical function, but together, okay, if I put the two function together, it makes a one picture, it can actually give me something else. Negative x squared plus 1, close parenthesis, go down to y2 and type in negative square root of negative x squared plus 1. So when I press graph, this is going to draw the first one and draw the second one. Oh, what is this? Let me squeeze my window a little bit. Let me go from negative 5 to 5. Maybe the graph will pop a little bit. Changing all of them. And when I press graph, it looked like this. What is this? This is actually a circle graph. This is actually considered as a circle graph. All right, I'm going to go ahead and tell you that a circle graph is actually not a function. And for the simple reason of, remember when we define what a function is, we just can't have the same x value. Because since I have two separate equations, I actually have two separate equations together as one graph. I actually can have the same x value because I can pick a positive 2 for, let me go here. I can pick a positive 2 for one equation. I can also pick a positive 2 for the other equation. And it's going to give me two different outputs. Actually, when I pick 2, it gave me error. So let me go back up. Let me just say negative 2, or let me say negative 3. Oh, crap. Let me just say negative 1. How about that? If I pick x equal to negative 1 for one equation, it gave me y0. Okay. Oh, sorry. Negative 1 is not a good choice. 0 is a good choice. 0, 1. If I pick x equal to 0 for one of them, it gave me for y value 1. If I pick x equal to 0 for the second equation, it gave me y value negative 2. So now I have the same x correspond to two different y values. So every time when that happens, then it's actually not a function. It's because now for my table, I can see 0, 1, and the same x value, okay? The same x value again have a different y value. So it's not a function. So this relation is actually not a function. Circle graph is not a function. All right, so let's solve for this one. Let's get y by itself and see my relation represents y as a function of x. So right now my variable term y is trapped inside the square root. So to get rid of the square root, I will need to square both sides. Since I only got two terms, I'm just going to square both sides together. So that gave me x equals 3 minus y squared. Since my variable term is negative, what I can quickly do is move my negative y squared to the left side and move my x back to the right. So I get y squared equal to negative x plus 3. So when I take a square root on both sides, my answer should be y equal positive and negative square roots of negative x plus 3. All right. So again, this is actually two functions put together as one picture. So let's type it in, okay? I don't know what it looked like because I know what each one looks like, but I don't know what they look like together. So I'm gonna say square root of negative x plus 3. All right, this is a square root function by itself, right? It's square root of x right there. I'm just adding a negative sign in front of the x and a plus 3 behind the x. But let's see what they look like together. Negative square root of negative x plus 3. All right, together. Oh, I'm still not. It looked like a U-looking shape, but this U-looking shape is actually point to the left. Okay, so if I go to my table, let's take a look. If I put x equal to 2 for one equation, so remember y1 was the positive one I entered it. Y2 was the negative square root I entered it. So if I pick a single value of x here, that will give me 2, 1 and 2, negative 1. So that means this is actually not a function. Y does not represent as a function of x. So this is actually called a horizontal parabola. All right, horizontal parabola opens to the left or open to the right. You can have a U open to the right. So that would not be a function. Quadratic equation give me a parabola opens up or it can open down. Those are called the vertical parabola. Vertical parabola is always a function. So this one is not. All right. Let's try this one, okay? All right, this time, this relation, if I want to solve for, made a mistake. This is not x. Sorry, let's rewrite the problem again. This is actually x equals 7y plus 3 over 5y minus 1, okay? All right, so this time my variable y is actually trapped between two separate terms, okay? One on the top, one in the bottom. So I got to bring the variable terms that is down here to the numerator. So since the whole equation only consists of two terms, I can use a quick cross product. So x times 5y minus 1 is going to be x times 5y minus 1, written this way because 5y minus 1 is two terms representing one denominator, so I put them in the parentheses. Set equal to 1 times 7y plus 3, still 7y plus 3. All right, so what do I do from here? Well, right now, one of my variable terms is trapped inside the parentheses, so what I can do is a quick distribution. So that gives me 5xy minus x equal to 7y plus 3. So now, once I'm finishing my multiplication, I'm having 4 terms. So out of the 4 terms, since I'm solving for y, my variable terms are 5xy and 7y. So one on the right, one on the left side of the equal sign. So I need to make sure they are on the same side. So what I'm going to do is move my positive 7y over. That means the negative x got to go to the other side. So on the left side now, I got 5xy. Positive 7y come over, become negative. On the right side, positive 3 still positive 3. Negative x come over, become positive. All right, so now these two are not like term for me to combine. So I cannot combine them. So the question is, how can I have variable term, my variable is trapped between two different terms. I got two variables right here trapped in two terms. How can I make these two into one single variable y? If my variable is trapped between two terms, how can I make it just into one variable? Just having one variable alone. Well, this is where factoring comes in. The greatest common factor between these two terms are y. So if I factor out the y, that will actually give me 5x minus 7. So this is just a y by itself now, equal to x plus 3. So now y times 5x minus 7 is only one term. So if I want to get y by itself, all I got to do is divide it by the coefficient 5x minus 7 on both sides. So my y is now equal to x plus 3 over 5x minus 7. So this is actually a rational function. It's a type of rational function. So let me graph it for you, okay? I got two terms on the numerator and two terms in denominator, so I will put my two terms in the parentheses. For the top, separate divided by separating with the denominator is also two terms, so I will put those two terms in a separate parenthesis, 5x minus 7. All right, go to standard window. This is what my rational function will look like. Here we go. So that is actually a function. Okay, it's actually considered as a function. So what is my domain? What is my domain? It looks like this right arrow, or you can't really tell. It looks like this part of the graph stops it right there. It's actually not. It's actually keep on going. You just can't see it because it's actually so close to the x-axis. Okay, so it's kind of hard to see. So if I draw my arrow like this, okay, or if I would squeeze my window, I might be able to see a little bit better. Or if not, you can always check the table, right? Does my function exist as x coming from negative? Yes, it does, because see, I keep on having the more left I go for the x-axis, my y value is actually what? My y value actually is a positive. Oh, that's very interesting. My y value is positive, so that means I'm actually cross over the x-axis at some point in time because my y values are positive. It's just staying very, very close to the x-axis. Okay, that's interesting. If x keep on going to the right, y value become positive again. So I actually also stays right above the x-axis. So as far as domain concerned, left to the right, okay. My domain got to be coming from negative infinity, okay. But here's the thing though, if you look at my answer, what is the restriction on my domain? My restriction on my domain got to be the denominator cannot equal to 0. So what number of x in my denominator will make my denominator will equal to 0. So all we're going to do is set the denominator not equal to 0 and solve for x. And then I can actually find my restriction on the domain. So my x cannot be 7 over 5. All right, so my domain is actually coming from negative infinity all the way to 7 over 5, but I can never be exactly 7 over 5 because that 7/5 will make my denominator equal to 0. Then the whole thing is undefined. So by not including the 7 over 5, I use parenthesis, union. The other part of the graph is actually going to be the right side of 7 over 5 and keep on going to the right. Okay. All right, let me go back and write down the domain for this. Okay, I know I don't have to, because if it is a function, I can write down the domain, but I can still write a domain. Okay, even if it is not a function. Okay, I can write a domain for any relations as well. So by looking at this parabola open to the left, the x value is coming from the left. How left is it coming from? Got to be coming from negative infinity all the way to where? What is this point exactly? Well, since I actually entered it two different radical functions put together as this one parabola, the way we find where the domain and range begins or ends, all we gotta do is set what's inside the radical equal to 0. I just need to set 1. I don't have to do same thing twice, because even though because there's two different answers, but it's still the same thing inside the radical. So if I set that equal to 0, simply move the x over. They tell me x is equal to 3. So in this case, the number 3 is actually where the domain ends at. Okay, it's because it's coming from negative infinity, it ends at 3. So since 3 is actually going to be a point on my line or on my parabola, I got to use a bracket. Okay. Now for this one, for this circle graph, okay, it looks like the circle graph is only from -1 to 1. All right, how do I know that? Well, I entered the two different radical functions put together as a circle graph. So if I was set what's inside the radical equal to 0, square plus 1 equal to 0, and solve for x, it will tell me negative x come over, become positive x equal to 1. So when I take a square root on both sides, my answer is positive negative square root of 1, which is still 1. So my domain begins at 1, and it ends at starts at -1, ends at +1, right? Small to large, left to right. And both points is actually on the line of this circle. Okay, so that's actually my domain for this circle graph. All right, so just quickly kind of show you how to determine whether the relation is a function or not a function, then write down the domain. All right, that will conclude this video. Thank you for watching.